Hi everyone, welcome back to this new video for the tutorial that uses Python to communicate with the microcontroller and have a nice display as you can see it right now. So within this video we will work on adding filters to the program we have created, and as you can see here we do have the blue one is a signal, the original signal, and there is the red one is a filter that we will build, and also the light green one is also another filter. We will play a bit and we will see what will happen when we add these filters and how to easily add them to our program. Okay, so if you want to apply a filter in your signal, just follow this video. See you soon.
This video will be focusing on applying a filter to reduce noise from the signal coming from the microcontroller. And within the whole tutorial, this is the video number 11 and the first one in the data management. We will see here how easily we can maintain the function upload to your signal and keep this program running very quickly and smoothly. All the code will be available on GitHub. You can download the file and follow this video. The language will be only Python, and the text editor will be VS Code. I would expect that people watching this video had an idea in the previous videos, so they can quickly and smoothly understand the content of this one. So the hardware that I will be using to play with the signal will have the STM32 F1 based board, which is the aka Blue Pill. We will use an FTTI, and this is to allow the interface, the communication between PC and the MCU. Finally, we will use a variable resistance or potentiometer so we can play with this ADC signal. From the tutorial perspective, it will be quite simple. We will apply the Savitzky-Golay filter. It will be one method, and after that we will apply the digital filter. This is a different method. We will be using the Scipy library, and finally we will have a display and review of the result. So let's go directly and jump to the first part. So what we will need to work on within this whole video is only then the data communication control. So we don't need to touch nothing else in the other classes and files. So what we have to do is also extremely simple. The first step, if we would like to add a function, you remember this self function master we just added here, so this will be used later on to be called by the GUI master, and we add our function name. So let's call this one the it's a difficult name, so let's call the Savitzky-Golay filter, something like this. Okay, and the Savitzky-Golay filter will be simply calling same name self dot, and we call the Savitzky-Golay filter too. So that will be the name of the function that we will be calling. Okay, let's save here, remove this one, and we can close this one here, add a jump just here, and add the method. And as usual, we have to add the self and the GUI. So let's go here, self, not self and GUI. And we almost have to just copy this one again, because that will be the final display, and we will change a little bit. I'll explain later on. So let's take X to simplify as much as possible our data manipulation is the GUI.x, and this is something we have done at the beginning later on in the previous two videos to make the data more compact, and Y is equal the GUI.y. So now we are going to apply the filter, and this will be, let's call it a W for example, and this one will be equal the Savitzky-Golay like this and dot filter. Okay, and what we will put is Y, and we put 1001, and this is how much we would like to make the computation. You can reduce, but you have to put a number which is not a binary number, means like 1, 3, 5 and go on so on, and put in here too. So this is a filter that you can find in the the library which is we need to add here, which is the Scipy library. So from Scipy like this dot signal we are going to import, and of course you need to pip install Scipy library, so Savitzky-Golay like this, and underbar filter. Okay, so the Savitzky-Golay filter is used here, so there is no issue anymore. And instead of displaying the Y now with this, the X, the Y, we are going to display X. So here, just X. Make it extremely simple. For the color here, to not like to be able to visualize both, so I will be selecting a different color. That's a number I put it, but you can play with the formula from the other colors and have a more sophisticated way to display it. So in the color I put like this, and that's all. That's what you need to show here. So based on this one, you have a new filter for the Savitzky-Golay. And I'm not going to display right now, but just to show you, let's go to the terminal. We will have the display later on to see both filters. And if I go for Python master, and let me show you the user interface here. And just by adding this one, as we organized well our functions, you can see that the Savitzky-Golay filter is already added here. And better to change Savitzky-Golay with the L. So here, Savitzky-Golay L here, and we should not forget to update it. The Savitzky-Golay filter and Savitzky-Golay filter. Okay, it will be exactly the same for the digital filter, but you can see that that's all. That's what you need to do, is you need your formula, and it's a less than 2 minutes update. Okay, so let's go for the next filter now. Same again. So now we are going to apply digital filter. So let's go here and add the function that we would like to add. So I will call it a digital filter. So digital filter. And after that, I'll be adding here self.digital filter. Just quick, simple wording like this. Okay, so let's take this one and create a new function. So I call it def directly, and we add the self and GUI. Self and GUI. So we can immediately copy most of this one. So I will put like this. I will change a little bit later on the colors and some points. So I need to add this one. Okay, so we still have this one, but this time we're going to need two other parameters, so B and A, and that will be equal to signal. So we will need the signal library. So let me bring it from Scipy. So here from Scipy, this is ways to call it, but import with this signal. Yep. And let's bring here, so signal BA is imported from signal and the ellipse. This one will have an ellipse like this, and we will need to input some parameters, and this one will show the number of parameters we would like to see. If you would like to get further details about this filter, you can take a look on the library. Just copy paste the name I will put later on, and you will get more details about how this is working. So 4 and then 0.01, this is the accuracy, and that what we'd like to do is 120. Then this parameter I have tuned up the signal late previously, and this is the best parameter I've found. Okay, and then we are going to use the gust method. So we put fgust here, but this is a name that you are free to choose, and we are going to use the signal and dot filt, so this one, and we just apply BA and then the Y hour, and the method that we would like to apply is the gust method. Okay, that's perfect. And then for the display, instead of W, we would like the fgust here, and from the color we are going to choose another different color, and as I explained to you previously, you are free to choose the color you want, as far as it's something that you can like differentiate from the original signal you do have. And here we are. So that's That's enough. That's the signal we need. So let's go here and run the GUI to check that everything is going well. So let's connect. Okay. And here we do have our signals quite ready. So the filters and function for filter are ready to run.
We completed adding all the methods, so now it's a good timing to start reviewing what would be the result. So let's take the user interface, which is ready now, and see our initial signal. So this is our signal start building here. And let's start by adding the filter, the first filter that we created, the subgo filter, okay? By adding here, you can see the color. So I'm not really happy with the color itself, but let's change a little bit. So let's stop here, close, and go jump again to the data. And what I will do, I'll be changing. So the line width, I will put 2 here and 2 here because it's not enough. And I will be putting this one here, changing them. That will be a little bit better for the visualization. So let's bring this one here, Control X, and bring it here. We should have a better view now. So let's take a look. Okay, the user interface is ready. COM3, the board that we need. And let's put here start. Okay, this is our signal start building. And let's add now the filter like this, not channel 1. We would like to see the filter for channel 0. Okay, so we can see that we do have a really good filter. So this is really small filter. So you can see the value is between 1 digit. So it's extremely low one and very good. But one of the problem, so let me show you the picture, just a moment. Camera here, where's the camera? Here, okay. So if I move a bit, let me show you here and here the display. One of the problem of this filter, if when I start moving, you can see this filter is not following well. So there is gaps in so it's a good smoother filter. So we do have a good smooth, but still not good enough. Now let's add the other filter we built. And this is the digital filter. So one of the problem of this filter, it takes a smaller digit, but it's a little bit, it has a little bit of a gap against the original filter. But the good thing is when we move here, you see how this filter is really following extremely well how the signal is going and the motion of the signal. So you can see one of the filter is really adherent to the signal, but when there's a big change, it doesn't really follow well. It smooths the signal and not sure if this is what we need. And the other one, which have a small gap between the whole signal, is following much better when things the variation gets really stronger. So I hope by the end of this video you saw that how easy we can add new functions and update the filters. Feel free to study other filters, study further the filter we have been reviewed within this tutorial, and you can play your own filter on the program. Thank you a lot and see you soon.